Hello everyone, welcome to Homework Help. If you find the video useful, please subscribe to the channel. In this video, we'll solve this trigonometry model problem. As per the problem, a sine function is transformed such that it has a single x-intercept in the interval 0 to pi, a period of pi, and a y-intercept of 3. Determine an equation of the function that satisfies these properties. So we have to use this given information to write the equation of this trigonometry model using the sine function. Let's start by analyzing the given information. We are given that this function has just one x-intercept in the closed interval 0 to pi. The period of this model is pi. That means the length of one full cycle is equal to pi. And we are given the y-intercept, which is equal to 3. In this problem, we are not given the maximum value or the minimum value for this sine function. We can use this information to sketch a graph for this sine function. We can sketch one full cycle. The period is pi. The midpoint of this cycle will be at pi over 2. The quarter points will be pi over 4 and 3 pi over 4. Pi over 2 is essentially equal to 2 pi over 4, and that's how we get 3 pi over 4, and the next one will be 4 pi over 4, which can be reduced to just pi. We are given the y-intercept 3. We can sketch a graph that satisfies all of these properties by assuming that the y-intercept of the graph represents the maximum value of the graph. That means the cycle of the graph starts at the y-intercept and ends at pi units at y equals 3. Since the function should have one x-intercept in the closed interval 0 to pi, we can assume the x-intercept is at pi over 2. Therefore, the minimum value for this function is 0. We can join these points to show the complete cycle. This can be the sketch of one full cycle of this function. Now we can analyze this full cycle to write the equation using the sine function. As per this sketch, the maximum value of the function is 3 and the minimum value is 0. We can use this information to find the amplitude and vertical translation for this function. The formula for amplitude is maximum value minus the minimum value divided by 2. I get 3 over 2. Next, we can calculate the vertical translation. The formula is maximum value plus minimum value divided by 2. I get 3 over 2. Now we can write the equation using the sine function. The general equation of a transformed sine function model is y equals a sine k times x minus d plus c. Different teachers use different letters for transformation constants. I am using a, k, d and c. The resulting transformations are the same. Now we can write the values of a, k, d and c. Let's start with a. we can assume there is no vertical reflection for this function. So A is equal to the amplitude value 3 over 2. We can find the value of K from the formula 2 pi over period. The given period is pi. 2 pi over pi can be reduced to just 2. We can cancel out the pi's. Next, we can find the value of d. D represents the phase shift. We are using sine function to write this model. As you may know, in the graph of the parent sine function, this point, which is the midpoint of the arm that's going up from left to right, is at the origin. This is an important concept about the parent sine function. This point has been translated 3 pi over 4 units to the right side. That means the phase shift for this transformed sine function is positive 3 pi over 4 because this phase shift is to the right side. The next one is C. C represents vertical translation and we calculated it as 3 over 2. Now we can use these values to write the equation of the model. So the equation of the transformed sine function is y equals 3 over 2 sine 2 times x minus 3 pi over 4 plus 3 over 2. This should be the final answer for this problem. So these are the steps you have to keep in mind to solve this problem. I hope you'll find this video useful. Please share it, like it, and subscribe to Homework Help. Thank you very much and have a nice day. Bye.